Look at question 2a. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. So we have a box here. What are we told about the box? We're told that the box is having a square base. Okay, so we have a square. Okay, something like that. I don't know if I've drawn a square, but the key important part there is the base is a square. Okay, so if it's a square, and then let's call the height to be h. Okay, now what do they want us to find? They want us to find the dimensions that will produce a box with a maximum volume. The box that will produce maximum volume. So the volume is of course going to be the base area and then of course multiplied by the height. The base area we have multiplied by the height to give us a volume, and then of course we've been given some information about the surface area. Now what's the surface area of a box? The surface area is going to be the base area we have plus the area of the sides. How many sides are there? Can we count them? So 1, 2, 3. Wait, which ones do we have? So there's that side there, 1. There's this side 2. There's this side 3. There's that side 4. So we have 4. That's excluding the base. So base area plus the 4 other sides give us the surface area. Okay. Yeah, that gives us a surface area. Of course, in fact, I was supposed to say we are focusing on the top part rather than the other side there. Yeah. So how do you find now the base area? The base area, we know if we're going to call a side to be x centimeters, it implies the base area is going to be x times x, since it's a square base, so that would be x squared. Now the area of the other 4 sides, remember we're calling the height to be h, so it's going to be in respect, since it's adding one side part of a square. For example, if you look at this side, you have a combination of the height and also the length of the square, so it's going to be a product of x and h. How many of these sides do we have? So we say therefore there's this one itself, and then there's this side, there's the other side there, there's one on top, the surface area. So there is a component of the height, right? So at least we've established what we have. So we've determined the formula for our surface area, which can be reduced as x squared plus 4xh, and then this is equal to 108, right? That's our surface area given in the question. Now what else are we told? We have to find the maximum volume, right? Maximum volume. So let's try to come up with a formula that will express our volume. So volume is going to be, the base area is of course x squared, and then multiplied by the height. The height, let's call it h. So we've come up with 2 equations. So we're trying to find the dimensions that will produce a maximum volume. So the goal here is to end up with only a single formula where we only have v as a subject, so that we can easily determine its derivative and then try to determine the maximum point, the point where we're going to have a maximum value, right? So in the second equation, therefore, we can work on our h. We can make it the subject, so that we substitute in the other equation. So if you make h a subject, you're going to have 108. This goes the other side, it becomes negative, and then you have the 4x attached, so divide by the 4x. So at that point you've made h a subject. You can make a step further by trying to divide by the 4x we have. So 108, you can divide it by the 4 if you want. So 108 by the 4. 4 into 10 should be 2. Remainder 2. 228 is going to be how many times? 7. So I have 27 over, since you are dividing by 4x, x remains. And the other part, x squared by the x will cancel. So I have 1x on top, on the bottom remain with just a 4 after dividing each by 4x. Now we are tribute of now substituting in the equation. So where we have h, we'll just put our x. 27 over x. So it's actually it was actually going to be very okay even without dividing the x. We just give ourselves unnecessary work. Okay, anyway, let's just go on. So we have 27 over x minus x over 4. What can we do? Our v is equal to, the x will cancel out, so that you have 27x. The other part, it will be x to the power 3. It will not cancel out. Okay. So we have now our volume expressed in terms of the base length, okay, which is x. So at this point I think we're now able to differentiate. So differentiating our volume in respect to the dimensions of a square length, we're going to have 27 for the first part. The other part is going to be 3 times that's going to be 3 over 4. The power reduced by 1, it becomes 2, right? So we've differentiated. Now if we're trying to maximize, it implies we're trying to determine the point where the derivative is going to be equal to 0. So if we are going to have to be equal to 0, 27 minus 3 over 4x squared equal to 0. At what point is that going to be equal to 0? So what do we do? So you're going to remain with 27 this side, the other side you're going to have 3 over 4 x squared. Okay, preserve this for some later job. So multiply by a reciprocal, 4 over 3, 4 over 3. This and that will cancel out. So remain with x squared equal to 4 times 27. 27 plus 27 is going to be 54. Is it 54? Yeah, 54. And then times 2. I think that should get us back to something like 108. But instead of doing that, instead let's divide by 3. 3 there it's 1, 3 there it's going to be 9. Yeah, 9 times 4. 9 times 2 is 18, times 2, 36. So you have 36. Okay. So we can try to find the value of x by determining the square root. So it will be plus or minus root of 86. So our x is plus or minus 6. So we've determined two values of our x. How do we know which one is the maximum, which one is going to give us a minimum? We don't know. So we can use a second derivative test. Okay, can use a second derivative test and see. But if you look at this, the reason why we are not going to even go for that is, if we look at what we had here, if you look at the sign there, the sign is negative. Whenever the sign is for the x squared part is negative, it implies what you're going to have. Since this is a quadratic function, there's no need of you to go for the second derivative test. You can even actually know that you're going to either have a minimum or a maximum. So only one answer is valid in this case. Okay, it's either have a maximum or a minimum for a quadratic. So therefore, in a case where you have got a negative sign, what you have is a maximum. Okay, you should know that right away. So in this case, it's a maximum. So now, since we're dealing with dimensions, obviously the positive value is the value that's going to be valid. So positive 6 will be able to give us a maximum volume of a box. Okay, so now where did we come from? Don't forget about our formula for the h. So this is for the length, right? So x is equal to that, that's the length. And then for the height, we said the height, we came up with a formula which was saying 27 over x minus x over 4. So you can plug in the value of 6 there. So 27 over 6 minus 6 over 4. Or you can go direct, go back to even previous form, which was 108 minus x squared, which is 36 in this case, over 4x, 4 times 6. Whichever is easier for you. Anyway, I'm having a calculator right away, but let me just use it. So 108 minus 36 divided by 4 by 6, right? 3 is what I'm getting. 3 into 27 is 9, 3 there is 2, 2 there is 2, 2 there is 3. 9 minus 3 is 6 over 2, 3. So our height is 3. So we now know the dimensions of our box, right? So our L is equal to 6, our height is equal to 3. Those are the dimensions of our box, which will produce a maximum volume.